Hello and welcome to today's lecture. Today we'll be looking at nomenclature of ionic compounds. So let's take it off from there. As usual, let us look at something beautiful I have for you today. The quote I got it from livehappy.com. It says, "Don't be stressed over something in the past because there is nothing you can do to change it. Focus on your present and then create your future." Such a beautiful quote and a food of thought for you. What now? Let's go straight into what we need to do today. In this lecture, we're going to be trying to achieve a particular goal, a single goal here. Now, the goal is to correctly name and write the formulas of ionic compound. And we know there are different categories of ionic compounds, and we're going to look at this as we move on. So now the first thing we're going to be looking at is naming binary ionic compound. Remember earlier, I told you when we did the first part of this lecture, formation of simple ions, that there are two types of ionic compound. There is the ternary, of course. I can just do a brief of the review. That if we have ionic compound, that there is the binary ionic. Binary ionic are those that contain two elements. Let me just make it easy. Just contains a metal. It has to contain a metal plus a non-metal. Can be a non-metal or a metalloid. A metalloid. Now, and then we have the ternary. The ternary ionic contain more than two elements. So usually it's more than two elements. And those elements, one of them, usually we have a metal, usually has to be represented plus a polyion. We're going to talk about this as we move on in this class. It has to have a polyion. Now, so in naming binary ionic compound, the customary thing there is that one, the name of the metal comes first, the name or the symbol. So the name or symbol of the metal comes first. You have to, so the metal, I usually tell my student that the metal is usually the chairman of that group. Now, in naming this, the names or formulas of this compound represents the minimum number of ions of each of the both monatomic ions, both the metal and the non-metal, that represents the simplest unit. So what am I trying to say? If you have a formula, let's say an example of sodium chloride, you want to get the simplest unit. So what it means is that if these numbers can simplify, you have to simplify them further to the simplest unit. And that is why actually we call these formulas, we call the formulas as formula unit. That's what we call them. We call them the formula unit of ionic compound. Now, if you look at a good example, let me use this to illustrate what I mean by this. Now, in writing the name, the formula unit of this ionic compound, now the metal comes first. You either write it first or name it. So if I'm going to name this, I'm going to put sodium first. So sodium always comes in first, either when I'm writing it or when I name it as sodium. And then I'll put the name of the anion. The name of the anion is named as chloride. This is sodium chloride. Of course, what do? We're going to we have chlorine here, remember? This is chlorine. We're going to remove the last part of this chlorine and then put ID. So it's going to be chloride, IDE. This is what replaces it. And when you put those things together, we have a name of a binary ionic compound or an ionic compound that contains two metals. So what are the rules? Let's just take the rules immediately. Now, these rules are in your note. I want you to read them to understand them. So the rules here, particularly, we're talking about this ionic compound. Now, the first part of ionic compound we'll be looking at are those of them that have a fixed charge. Fixed charges means that we're only concentrating on group 1, group 2, and group 3A element. These are the ones. So we're talking about the metals that are in the main group metals. In fact, that's another name to say. We're looking at the main group metals or the representative group metals, which is group 1A, group 2A, and group 3A. Now, the name of the cation always comes first. We have to come, and the name of the anion will come second. Remember the one I told you earlier. Of course, there are two ions that make this up. You have, in the previous illustration I had here, you have sodium and chloride. Now you're going to name the sodium differently, and then you're going to name the chloride differently. So what are you going to say? So sodium, of course, in naming the metal ions, it just says the name of the metal and put ion. That's how we name them. Whereas the name of the non-metals or the anions, we just have to replace them with what? We have to replace them with the anions. We have to replace them with, okay, now I'm going to put the anions here. So if you want to name the anions like chloride ion, how do we name it? We're going to name it this way. Let me take this off. So we're going to say this is going to be chloride. We're going to put the IDE on it. So again, if we have calcium ion too, we're going to say this is calcium. So this is calcium ion. So the name is just what you say. So when you are going to name them, of course, you don't have to put in this anymore. You have to put ion. So you just say calcium and then you join it with the name of this. So if I have here again, if I have oxygen, of course, O2 minus, I'm going to call it oxide because this is the oxide anion. And then if I have nitrogen, okay, again, if I have, let's say, nitrogen here, nitrogen is N3 minus, I'm going to call it the nitride. So what do? You take the root name, which is the beginning part, and then the ending is going to have the IDE. So let's practice this as we move on. Now, these are common names of both the monatomic ions, both the anions and the cations. So if you the common anions we're going to see, particularly the monatomic ones, is lithium, sodium is here, potassium, cesium, beryllium. Then if you go to the anions now, hydrogen at times acts as an anion. When it acts as an anion here, we use it as hydrodion. So this is fluoride, chloride, bromide, iodine. So iodide, oxide, sulfide, selenide, nitride, phosphide, SNide, and the rest. So we're going to use this scheme in trying to practice the nomenclature in the next few pages. So it says name the following binary ionic compound. We'll start up immediately. So the first thing you want to look at first is to know the identity of these metals, and you're going to always have your periodic table by your side. So we look now. This is K is potassium, and then this is oxygen. So what it means now, you are going to look at the combination of potassium and oxygen. Remember, you're going to give the name, the full name of the cation. So what we're going to say first here is we name this. This becomes potassium, and then you give space to name the anion. The anion here is oxygen, but to name this an anion, it has to be oxide ion. So we're going to put oxide. It becomes potassium oxide. Again, remember, now this, let me now make a little bit of an emphasis. Naming this binary ionic compound with fixed charges means they have only one charge. And those charges, like we did in the previous lecture, is that the charges of these group elements are determined according to their group. So our interest is group 1. This is the group 1A. Of course, this is the group 2A. Group 2A. What it means is that the charge of this group will always be +1. The charge of this group is going to be 2 plus. This is 1 plus, this is 2 plus. The charge, now these guys are the transition. These guys have variable charges. We don't have any interest in them yet. We're not going to go to the group 3. The group 3 elements will have what? A charge. This is where aluminum and gallium, you see aluminum and gallium will have a charge of 3 plus. So the charges are fixed, provided they remain in this group. So here now we're going to name this one. So magnesium is in group 2. Of course, it has a fixed charge. This will be magnesium. Nitrogen, we name it as what? Nitride. And again, we have to use gallium. Gallium again is in group 3, has a fixed charge. So we're going to call it gallium, is the full name. And then sulfur is in group 6. Of course, the sulfide ion, we're going to name it as sulfide. So it's going to be SUL. This is the sulfide. And so this becomes gallium sulfide. Now, I want you to pause this video at this point. Try these problems yourself. I'm going to give you 30 seconds, and then we'll come back and continue working on them. Okay, yes, we'll get back to it. Now, again, this is aluminum. Aluminum is in group 3 again. Of course, all these ones we're naming will have a fixed charge. Now, so it becomes aluminum, has to be written full. That's the name of the cation. The anion, this is bromine. Bromine is in group 7. And then it's going to be, we're going to name it as what? A bromide ion. We have to put the IDE. Again, lithium. Lithium is in group 1. So this is going to be lithium. oxygen will be named as oxide. Again, this is barium. Barium is all in group 2. If you look at it here, so we're going to call it barium. This is barium. And then again, this is nitrogen. We'll name it as what? Nitride. So that is how we name these ones. Now, let's also name a few other examples. Again, you can always pause this video, try out these problems yourself at any point in time, and come back to them. Now, remember what we did earlier was we had the names, and then we had to name them. In this case now, the names are given to you. You want to write the formula unit. Remember, I told you the formula of these ionic compound are actually called a formula unit. So what are we going to do? Again, remember, these guys are fixed charges. We're going to look at them. Sodium here is in group 2. This will be +1 for these guys. This will be +2. And this will be +3. Those are the ones we're interested in now. So this will be sodium. So sodium will always have a charge of +1. So we're going to say Na plus. And then selenium, we look at it. Selenium is in group what? Remember, this is group 6. Group 6 element will have a charge of -2. This will have a charge of -1. Group 5 will have a charge of -3. So this is selenium. Selenium will have a charge of what? -2. So we're going to say S2 minus. So what are we going to do next? Remember, when we did this thing earlier, in the last lecture where I talked about formation of simple ions, what they simply do is to transfer these charges or balance it themselves, whichever method you want to use. So I'm going to use the balancing method. Now, this 2 is going to go to sodium, and then this 1 here as a magnitude will go to this. And what do we have at the end of the day? If we now name this, we're going to be having Na will take the 2 from sulfur to become 2, and from selenium, sorry, this is selenium, please, this is Se, yeah. And then Se will take the 1 from sulfur and become this. So this becomes your sodium selenide. We'll go to the next one, barium and nitride. Again, barium is in group 2. Let's look at it. Group 2 has a charge of +2. So we're going to say Ba 2+, and then nitride is what group? Look at it. Is in group 5, and it's going to have a charge of -3. So we're going to put it here, 3-. Again, when we swap these charges, this is going to go to this one here, and this one is going to go to this one here. And what do we have at the end of the day? We're going to have Ba is going to take the 3 from nitrogen, and the nitrogen is going to take the 2 from this. And this is barium nitride. Again, we do the same thing here. Now we see this is strontium. Strontium here is 2+ in group 2. Let's look at it. Group 2. And then oxygen, again here is -2 because it's in group 6. So what are they going to do? If they move these charges, look at this is going to move this charge to here. This is going to move this one here. Remember again, since the charges are equal, let's write it first. So you're going to have SR2O2. But you can't have this. Remember what I told you. These formulas represent the minimum or the simplified form of this unit. So what is going to happen? You're going to divide this by 2. If you divide this by 2, at the end of the day, you're going to have SRO, and this becomes the correct formula of strontium oxide. At times, I see students make these mistakes, and they always lose points when they do that. You have to simplify those numbers when you see them, when they can cancel each other. So it's a kind of an algebraic minimum, simplified minimum of these units. Again, aluminum and iodide. So we're going to have here aluminum is 3+, and then iodine is 1-. Again, this is 1, this is plus. Aluminum is in group 3 again. Remember, this is +3. Iodine is in group 7, and the group 7 guys have -1. So they're going to swap their charges again. If they swap their charges, you're going to have what again? So aluminum will take 1, you don't put the 1, where iodine is going to get the 3. That becomes the formula. The same thing here. We're going to do this. Remember, you can always do this with the balancing of the formulas. You don't have to always do it with this one. You can always do it with the balance. Okay, I'm going to solve this with the balancing of the formula so that will be easy. So, okay, in this one now, remember, lithium, okay, well, I'm going to say lithium is in group 1. Let's look at it. Remember, this is group 1. This is lithium, is +1. And then phosphorus is in group 5. Let's look at it. It's in group 5. So is in group 5, so this is going to be -3, and then so this is P3-. Now if you're going to balance this, now let's try to balance this. I'm going to try to write my bar here to balance these charges. Now we want to balance this to be equal to 3-, so have 1 here. That tells you that you just simply need 3 of this guy. This will give you 3+ to balance the 3-. 3 plus plus 3 minus is going to give you 0. So you need 3 of lithium and 1 of these to form the solar. So when you add all this together, what is it going to give you? It's going to be Li3 and P. This is lithium phosphide. So like I said, you can always do this whichever way you want. It doesn't matter. It could be anywhere. So we have this one here again. This is strontium. Strontium again is 2 plus. Is in group 2. Let's look at it. It's group 2. And then sulfide is in group 6. Let's look at group 6 here. This is group 6. The charge will always be -2. Sorry. The charge will be -2. So sulfide is -2. When you see that the charges are equal, the best thing to do, they just cancel out each other. You bring them, just cancel them out and bring them to complete formula and balance. Now, let me say something again. When students write the formulas of compound, they tend to forget to remove these charges. A compound, a neutral ionic compound doesn't have charges. It is neutral because the charges cancel out each other. So leaving up those charges there is going to also lead to you losing some point. Now, we now go to the next category of compound we need to look at. Now, binary compound that have variable charges. Now, our attention here will be focused mainly on the transition element. The transition, we call them the transition element. Transition element. Transition element, and that's why they gain that name, because their charges differ. So some metals, especially those of the transition and the inner transition, we call them the D and F block element, form more than one type of charged ion. They form more than one type of charged ion. A good example here is copper can form a charge of 2 plus, it can form a charge of 1 plus. So how can you distinguish between these two charges? The best way to distinguish two charges is to name the exact charge. Now, what it means is that this charge will be called copper 2 ion, and this will be copper 1. That's exactly what I have here. So if you want to name those compounds, this is copper 2 ion. So we're going to say Cu2 plus simply means copper 2 ion. And then Cu1 plus simply means copper 1 ion. So if you now want to name the compound, you have to specify those charges. So the onus lies on you to identify what charges are those. So if you want to name this, now look at this one and this one. This is the two formulas that are formed between copper and chloride. The difference between these two is this here, copper has a charge of 2 plus, and here a charge of 1 plus. And because of that, it forms two different compounds that have two different chemical properties. So if we're going to name the first one, this becomes copper 2 chloride, CuCl2, because chlorine is 2 minus, chloride ion is 2 minus, and it has to be 2 to cancel out the 2 here to be 0. And here it is Cul2, here it is 1 plus, because this is -1, this has to be +1 to cancel them out. And these are two different compounds. So we're going to apply this knowledge in the next examples as we move on. Now, in doing these problems, I advise students, the best approach to use in doing these problems, in doing the variable charges, is to use the balancing of charges method. That is the best thing to use. Now, let's look at this. So name the following compound. Now, this is CrS2. We know that the sulfur belongs to group what? 6. And the group 6 guys will always have a charge of -2. So the charge of this guy is constant. So let's try to write it as a balance equation. So we don't know the charge of this one. We don't know it. Let's call it X. But we know that sulfur. Sulfur is 2 minus. Now, how many atoms of sulfur do I have here? We have 2 atoms of sulfur. So what are we going to do? I'm going to say 2 minus and another 2 minus. That means I have 2 atoms. Now, if I add these two together, I'm not adding the atoms, remember, I'm adding the charges. So if you put these charges together, it's going to give you a total of 4 minus. Now, for you to balance this 4 minus to give you 0, what it means is that you also need another was +4. So what it means is that the charge on this guy is going to be +4. Having known that charge, what do? Remember, the rule says we're going to say the name of the metal, just like we did for the ones with fixed charges, but we have to put in Roman numeral the identity of that charge. So let's do that now. What do? Let's do that. So now we know the charge is 4. So we have the charge already determined. Let me put, no, that's not what I want to do. I want to go here. Now, this is the charge already +4 determined. If I go back to my red, let's now name. So it's going to be chromium. I know this is, if you look at it, you now look for your chromium. This is chromium. So this is going to give you chromium. And then what else do? We have to put the charge in Roman numeral. So the charge here is going to be chromium. This is 4. In Roman numeral means IV. And then you put the name of the anion. And the name of the anion here is what? Sulfide. So that becomes the name of this compound. We're going to apply this in the next few examples. Again, let's look at this one. If you're going to do this one again, manganese, we don't know what it is because manganese is here. Look at it. It has a variable charge. All these guys here have variable charges. They have variable charges. Variable charges. That is what we call them, the group type 2 binary compound. So now we don't know what manganese is, but oxygen is in group 6 and it has a charge of what? 2 negative. However, there are 3 atoms of it, so we're going to try to put the 3 atoms here and know what. Now, if you add all the charges here together, it's going to give you 6 minus. What that simply means, for you to cancel 6 minus, you need what? A 6 plus to give you 0. So what that simply tells us is that the charge on this guy has to be plus 6. And then when you want to now name this, we now know the identity of the charge to be what? 6 plus. So it's going to be manganese. The name of this is manganese. Manganese 6. 6 means Vi. Manganese 6 oxide. That's how we name this compound, and that is the correct name. Again, we move on to the next one. Now, TC means technetium. That is the name of that compound. The name is technetium. Now, technetium is also a metal with a variable charge. So we're not going to preempt it. What do? We know nitrogen. Nitrogen belongs to this group and they have a charge of -3. So we know that, and here there's only 1 atom of it. So we know it is 3 minus. And 1 atom of it. That makes it this. For it to balance 3 minus, you need a 3 plus. So the charge on technetium is what? Is 3 plus. So to name this, we're going to call it what? Technetium 3 nitride. And that becomes the name of the compound. Let's do the next problem. So at this point, I want you to pause the video, try this out to yourself, and then continue playing the video to see if your answers are very correct. That is what we're going to do at this point. All right. Again, remember these are the variable charges. Again, they're variable charges. We don't know what they are. So now, what do we have? We have MO. MO means molybdenum. We don't know the charge of molybdenum, but we can figure out that of what? Phosphorus. Phosphorus is in group 5. And the group 5 element will always be what? -3 charge. So what do? As usual, we try to write it out. We don't know MO charge, but we know that of P. P is -3. And I have how many atoms? I have 2 of these here. So if you add this total charge, it's going to give us 6 minus. And for you to cancel 6 minus, you need what? A 6 plus. And so that is exactly what you need here. And then when you name this thing, what are we going to have? We're going to have molybdenum 6 phosphorus. You have to name it as phosphide. That's the name of the anion, as molybdenum 6 phosphide. We go to the next one. Gold again is part of those guys we're talking about. Gold is part of those guys that we've been talking about. Is also a transition metal. It is located at this point again. Au. We don't know the charge, so we're going to just say Au. We're going to say Au. We don't know, but we know chloride is -1. Of course, remember, chlorine belongs to this group, and they have a charge of what? -1. So we know it will be -1, but we have how many atoms of it? You don't need to put 1. Yeah. So we have 3. Okay, no, that's not going to give me enough space to do what I want to do. So I'm going to write it on top of these. Okay, remember this, we're talking about these guys that are -1. So I'm going to say Au, I don't know what this is. So this is -1. There are 3 of it. And if I balance it, this is going to give me 3 minus. That means I need a 3 plus to balance it. So this should be 3 plus. And again, if I name this, this is going to be gold. That is gold 3 chloride. And the last but not the least in this one, again, FeO, one atom of it. So, but we know that oxygen itself is 2 minus because it's in this group, and this group, the charge is -2, and 1 atom of it. Now, for us to balance it, there has to be 2 of these to make it 0, Fe. So the name of this is going to give us what? Ion Since the charge is 2, we have to say what the charge is, iron 2 oxide. So that is how you do this problem. And again, now what do we do? Now the first one we got the names and we wrote the formula. Now we have we got the formula and we wrote the names. Now we have the names. We want to put them to their formula as usual. These are easy to do because they tell you what the charge is. So this is iron 3 chloride. So it's easy. Now, iron 3 means Fe3 plus. The charges are given. No even need to think about it or look. So what you simply need to do is to know the identity of it. Just recognize that this guy belongs to this group of metals. That's what you want to do. So Fe3 plus chloride, of course, is in this group. And this group, they must have a charge of -1. So what do? You swap the charges. This goes to this guy, and this goes to this guy. And what does that give us? That gives us FeCl3. Remember, this Cl has to be a capital letter. Again, manganese 4 oxide. You see this one now. Manganese means the manganese need to have a charge of 4 plus. And oxygen, of course, is in this group, and this group of guys usually have -2, so it has to be 2 minus. If they swap their charges as usual, what is it going to be? It's going to give you manganese. It's going to take the 2 from oxygen, and oxygen is going to take the 2 from manganese. Now, remember, I said it has to be a simplified unit. This is not simplified. So what do? I have to divide both sides by 2. And if I did that, I'm going to have manganese will now become 1. You don't need to show that. And oxygen is going to be 2. So this becomes manganese 4 oxide. Now, chromium 2 sulfide. Again, chromium is 2 plus. That's what it's telling you. We always know sulfur to be what? 2 minus. Since the charges are equal, you just cancel them out and bring down the name of the formula. That's simply what you do in this case when the charges are equal. Again, you know that sulfur belongs here, and that is why it has a charge of -2, and chromium is here. We have to determine that through the sulfur, and that is how you do this kind of problem. Now, at this point, I want you to pause this video, try out these problems yourself, and then get back to them. It says, write the formula unit for the following compounds. All right, so gold again, we don't know. No, this is easy because in giving the names, we have the charge. So here, the charge is 3. So we have to, Au is what? 3 plus. And we know that phosphorus is in this group. Is in group what? 5. And group 5 have a charge of -3. So this will be P3 minus. So since the charges are equal, what do we need to do? Just put it together and then the cancel out. Again, technetium 2. Technetium here is Tc. It is 2 plus. Sulfur again is in this group. They have a charge of what? -2. So this is 2 minus. Since they're equal, what do? Just bring them down. It's going to be TCS. Vanadium 5 oxide. Vanadium again is here. Remember, we're focusing on these guys here. This is vanadium. Now, but here, vanadium is 5. So it's easy. Vanadium is V, and it is what? 5 plus for us. And then oxygen, of course, we know is in this group. Oxygen is in this group. So it is. Oh, I talked about oxygen earlier when I've not even used it. So I think I used sulfur earlier. This is not oxygen. Oxygen is going to be O2 minus. So simply, they're going to swap their charges. That's what they're going to do here. If you swap these charges, they're going to be V is going to take the 2 from oxygen, and O is going to take the 5 from oxygen. And this is the formula of vanadium 5 oxide. All right, so we go to the next group of compounds we need to name here. They are called ternary ionic compound. Now, the rules for naming ternary ionic compound, remember, ternary ionic compound are those compounds that contain a metal and a polyatomic ion. I talked about them earlier. Now, the names are essentially the same. We usually give the name of the metal first as usual. It will now be followed by the name of the polyatomic ion. So what you simply, again, both of the charges have to cancel. The difference here is that you have to recognize this polyatomic ion and memorize them. I'm going to give you a list of those you need to memorize in my worksheet. Now, if the polyatomic ions occur as more than one unit, you have more than one of them, you must have to use a parenthesis or a bracket to show that. We're going to see that as we move on. And then again, the charges of the metals. If you have anyone that has a metal that belongs to the transition metals, you have to specify the charges of those metals as well. So let's try those with these examples. But before then, let's see the common polyatomic ions that are used in every day. These are the common polyatomic ions used every day. Now, the only positive or the only cationic polyatomic ion you come in contact usually at this point is ammonium ion. The rest are anions. So this is acidated ion, carbonate ion, chlorate, and all the rest of them. So we have them and their names here. You're going to see them all by the side. So we're going to try to use these to now do those problems. So let's go to the next page and then deal with those problems immediately. It says name the following ternary ionic compound. If you look at this, calcium, of course, belongs to this group. So it does not, it only has a charge of 1 because it's in group 1. Sorry, calcium is in group 2. It has a charge of +2. Sorry, my bad. This +1. Now, this is calcium here, belongs to this group 2. And then, what is the name of this polyatomic ion? Remember, it is in group 2. We don't need to say the charge. We don't have to name the charge with a Roman numeral. However, we need to say what the name of the polyatomic ion is. So PO4, let's go to where it is. If you look at it, where is PO4? PO4 is phosphate ion. So how do we name this? We go back to it. So we're going to say, or always give the name of this first. So it's going to be calcium. What is the name of the polyatomic ion? Is what? Phosphate. So naming these guys are much more easier because you just say the name of the polyatomic ion. Let's look at this one. This one say, of course, G. This is group 3. So they have a constant charge. We don't have to name the charge. So this will be gallium, the first one. NO3, what is it called? NO3 is actually the nitrate, but I want to show you, since you're starting to know that, this is called nitrate. So we're going to call it gallium nitrate. Again, we go to this. Now, if you look at this now, Cu, copper belongs to what? The transition series, the variable guys, the variable charge guys. So what it means, we have to specify the charge. How do you determine that? Again, let's use the balancing. OH minus, what is it? Let's note the identity. Let's know the identity of OH minus. Sorry. The identity of OH minus is this. Let's go. So this is the hydroxide ion. If it is called hydroxide, it has a charge of -1. So how many atoms? We have 2 of them. Remember what I told you. Because there are 2 of them here, a parenthesis was used. That must be consistently done. So if you add this total of the charge, it's going to be 2 minus. So for you to cancel 2 minus, you need 2 plus. That means the charge of copper here has to be a 2 plus. If that's said, so what will now be the name of this? The name of this compound is going to be copper will come first because it is a variable group of metals. You have to say the charge. The charge is what? 2. And the name of this OH is called hydroxide. So this is called copper 2 hydroxide. That is how we name that compound. Again, let's name these ones. Again, in trying to name these ones, problem 10, ion here again is, if you look at it, ion belongs to these variable guys with the variable charges. So what it means, we have to figure out the charge from the cation. Now, what is the name of this cation? This is called sulfate. I'll still take you over there to see. SO4. SO4 is called the sulfate ion, and it has a charge of what? It has a charge of 2 minus. So what do we do? And we have 3 of them. So I'm trying to try to balance them. This SO4 2 minus, another SO4 2 minus, and another SO4 2 minus, because there are 3 of them. Here, 1, 2, 3. And then we don't know the ion. Now, if you put a total of this charge, it's going to give you 6 minus. To balance this charge of 6 minus, and there are 2 atoms here. Remember, there are 2 of these already. So that means we need 6 here to be the charge. But because there are 2, if you divide the 6 by 2, it's going to give you 3. So this is going to give you, you need to have 2 of this guy to balance the 6. So if you have this, so this is going to be a total of 6 plus. So for you to now name this, the name of this compound is going to be what? Ion 3. The name of this SO4 is called sulfate. The same thing we're going to do here. Now this one, cesium. Cesium belongs to group 1. It has a charge of +1, so we don't need to name the charge. What we need to deal with is to know what this identity of that. The identity of that guy is actually called iodate, IO3. So let's look at it. Iodate ion is called iodate ion. So what are we going to call it? We'll now go back to it. We're going to say it is cesium. You now say the name, so it's going to be cesium iodate. You don't need to put the parentheses because this belongs to group 1. And again, we name this Mn. Oh, Mn is a variable one, so we have to determine the charge. How do we do that? We know Mn, but we don't know the charge. But we know that CO3 is 2 minus. How do you do that? You have to. Now, some of these things you need to memorize. What is the CO3? CO3 means the carbonate ion, and it has a charge of -2. So we go back. Now, we go back. Yeah, it has a charge of -2. So, and there are 2 of them here because of the bracket. So let's write another one. CO3, 2 minus. So if you balance this charge, 2 minus plus 2 minus will give you 4 minus. To balance 4 minus, you need +4. And that means this is going to be of +4. So what is now the name of this? So we're going to name this. Oh, I don't have much space here, but it's fine. I can just draw arrow and come and name this here. So the name of this will become manganese. Of course, this is 4. 4 means IV, and then this is called carbonate. Manganese 4 carbonate. That is how you name that. Now, the last but not the least is what we're going to do now. So we're going to now begin to now go from, you have the name of the compound, we're going to be writing the formulas. And we're going to try to do this with the same process. So what I want to do now is to pause this video a little bit, walk through these problems, and come back in the next 30 seconds. And that will be the last problem, and we'll finish that. And you should be all good with nomenclature of ionic compounds. Okay, let's do that really quickly. So potassium nitrate, that's what we have here, right? Potassium nitrate. So what do? We quickly move. So now it says potassium belongs to group 1. They have a charge of 1 plus. So where is it? It is here. So what are we going to do? We're going to say 1 plus nitrate. What's the formula for nitrate? You can go back again and check that. The formula for nitrate, let's look at where the nitrate, we use it for NO3 minus, and it's 1 minus. It's just 1 minus. So we're going to say NO3 minus. Since the charges are equal, I usually tell you just bring them down because they will easily cancel out, and this becomes the formula of potassium nitrate. Here we have copper 2. Good enough. Copper 2, the charge is given, so we know it is copper 2 plus. What about phosphate? Phosphate, you have to also know that, but we can go back and check what phosphate looks like. Phosphate, again, when we check it, PO4 3 minus, that's what it is. So PO4 3 minus. So we're going to have it here. It's going to be PO4 3 minus. Again, they have to swap their charges. Now, this charge is going to go to, wait, I'm going to make it clearer. Now, this charge is going to come and go to this one, whereas this one is going to go to this one. Again, remember, you're adding more than 1 unit here. What it means, you're going to use a parenthesis, not to confuse it, a mathematical parenthesis. So it's going to be Cu, we get the 3 here from phosphate, whereas phosphate is going to get a 2 from what? It's going to get a 2 from, it's going to get a 2 from what? Copper. So this becomes the formula of copper 2 phosphate. Again, you have to remove the charges because they become electrically neutral at this point. Now we have here aluminum chloride. Aluminum, of course, remember, belongs to group 3 and it has a charge of +3. So we're going to write it Al3 plus. And again, chloride is, you can check it out to yourself. Again, chloride is ClO3 minus. Let's see. ClO3 minus is 1 charge. That's the chloride. So we go back and situate that. So what it means is that they need to swap their charges. Remember, this one is going to go to aluminum, and aluminum will give this one this. So what's it going to be? You're going to have Al. I'm going to remove that. Wait, I don't need this. So it's going to be Al is going to take the 1. You don't need to show it. But now ClO3 minus, look at it. You're going to put 3 here. There is more than 1. You need to put a mathematical bracket or parenthesis. So this becomes the formula of aluminum chloride. The last but not the least, ion 3 carbonate. Again, ion here is 3 plus. Carbonate here is what? CO3 2 minus. We used carbonate earlier. If they swap their charges again, this charge will come and go to ion, and this charge will come and go to carbonate. And what do we have? So ion is going to get the 2 from here, from carbonate, whereas because you're going to put more than 1 unit of carbonate, you need the parenthesis, so it's going to be CO3 bracket 3. This becomes the formula of ion 3 carbonate. At this juncture, we've come to the end of this class. Thank you again for listening, and do have a wonderful time ahead of today. And bye.